Hey guys, Mike here from Applied Engineering and Design, and I wanted to go through a pretty cool video here for you about making a logo or making an emblem. I get a lot of people asking me that they want to do an emblem for their car or they want something for their business, and they want me to CNC something out of a block of aluminum or titanium or something special. So figured it would be cool to go through a little tutorial on doing something. So I loaded up our Applied Engineering and Design logo, which was made in Illustrator. By importing that into Rhino, it brings the curves in perfectly, and you can see they're closed curves, and we can select pretty much everything. So I thought it would be good to show how RhinoCAM can really utilize these curves, and we'll just make something out of a block of aluminum, let's say, and we'll kind of go from there and show you all the different ways I would create this, from using an end mill, a small end mill, to a little V mill to engrave a line or something of the sort. So we can see how it comes out in different ways. So let's get started right here. So once the logo is loaded, the first thing we're going to do, as always, is go ahead and create some stock. Now, if we hop over to perspective, we can see that it's going to create, and if I ignore, what it's doing is creating it basically how exactly we would do it anyways. But let's go ahead and say that we want a little bit bigger. It's actually quite huge here. It's looking like it's 40 inches long by 40 by 24, and creating about 5 inches of height. So, excuse me. We'll leave it as is because we're just kind of playing through it here anyways. But I do want to make it a little wider. Let's say we do 48, which is 4 feet, and let's say 30 inches tall. And for instance, we're only going to do maybe a 2-inch block. So if we set that and look at the stock, that kind of gives you an idea of what it would look like. Let's head over to top, and it's not centered in it right now. So what we'll do is we're going to align the stock, and we're going to do Z alignment top, center, and hit OK. And that's exactly how we want it to look. And we're going to leave it right here. We're going to leave our 0 right in the center, and if we look, our Z value is right at the top as well. So that's perfect. So in reality, when we load this into the machine, we would find center, and then we would go ahead and touch off the top. Very easy with a probe. So let's get started here. So what we're going to do is kind of need to decide how we want to do it. So for instance, I think what we'll do is machine down the surface of everything and raise up this part right here so that the applied is sort of sticking out. And then I think I want to do the same for the gear on the top, but nicely that's a closed piece as well. One thing we may want to do with this straight line is if we want that raised as well, we're going to want to offset that and sort of incorporate it right into this as well so we can get a final thing. So if we go ahead and let's just do offset. And for instance, we come up and hit both sides, and basically that gives us a 1/2 inch offset. And let's do the same on this, both sides. We got this nice little offset here. So what I'm going to do is come in and just connect that. So we end up with this nice square on the top and on the bottom. Oops. Make sure we're end to end. Just like that. All right, so now what we want to do is actually make this one solid curve. So what I'll end up doing is selecting this, the ends, that bar essentially. We're going to go ahead and select this as well. And we want to essentially make this a single shape. So what we're going to use for that is curve boolean. Start typing curve bool. And now this is going to wants us to select the regions we want to keep. So I'm going to select that, which is what we want. I'm going to select all of that, and we're going to make sure that these become part of it as well. And we can decide if we want to delete the regions or not. I'm going to say delete no, so we have all the curves anyways. That way it's a separate curve. Now I can choose between the original curve or this nice curve that's around the whole outside of that. So by doing that, I can now machine down the surface of this using that around. So let's go ahead and jump into our perspective here, and let's create our first facing operation. So it looks pretty small. So what we're going to do is we're going to need to do a couple facing operations here. So let's select what we're going to do. We're going to select that one big curve. One other thing I forgot to do, we need to join this into one curve as well, just to make life a little easier. I'm going to hit join. So now we've got one curve there as well. So go back to what we were doing, facing, select our curves. I'm going to choose that curve, and choose that one, and that one. So tool, let's create a tool, an end mill, and we're going to start off with a 1/2" end mill. We can zip through it. Speeds and speeds, load, we're going to leave everything kind of alone for right now, since we're talking more about just the general machining operations, everything. So save as new tool. Our clearance plane is fine. Go into roughing. So with the roughing here, I don't want to leave a full 25 thousandths. I want to get it nice and close. We'll leave 10 thousandths, and we'll leave the tolerance alone. We're going to bump this up to 50%. All right, so our cut levels now, our geometry is at the top, and we want to offset this a little bit. So we're going to do a total cut depth of a 1/2", and let's do it in 2 passes. And we can just do a nice 2D exit, 2D entry. We'll apply it at both cut levels. Arc fitting's already on, but I want to tighten it up a little bit. 2000s, and we'll turn on smooth cut connectors. So as you can see, what it did was machine down all the insides of it. We want the exact opposite of that. So let's go ahead and change what we want to do here. And our control geometry, I selected those as our drive regions. We got 2 options here. I can change them to be the avoid regions, so it'll machine the whole surface except for that. But I think what we'll do is we're going to go ahead and just draw a square that fits the outside of this. Come in here, and I'll just come in. The nice thing is I can make it just slightly bigger than it as a drive region. Back, let's go back in here. And let's remove all select regions. Now we're going to select this outside as a drive, that full curve, that one, and that guy right there. Now if we generate, there we go. Now it's going to be all on the outside of it. Because this is so big, we might actually be okay with the 1/2". So let's take a look at what it looks like. Let's speed it up. And that actually did a pretty cool job. The only thing it can't do is it couldn't fit down in between this bottom one here. So what we can do is we can come back into here and measure what this is by going to Analyze, Distance, and we're going to measure that to that. And it says 0.4545. So that's why the ½ inch can't fit in there. So what we're going to do is we can actually utilize remachining. Same drive regions. Our tool now is going to be, we're going to take it down to a 1/4 inch. And change this to 1/4. Save as new tool. And it asks us if we want to change the tool number, and yes. I'm going to hit OK. Feeds and speeds we'll just leave alone. Cut parameters. Now we're going to have 0 stock. And we'll set tool diameter 50% again. And the reference tool diameter we're using is 0.5 because that was the tool we used before. And we're going to do part offset facing. And entry exit, we're just going to leave alone for now. Arc fitting, let's turn back on, 2000s, and smooth cut connectors, and let's see what this guy does for us. May take a second because it's got to recalculate what it did for the previous job. And then again, recalculate everything that it needs to do in the corners. And you can see if we go into perspective, it took care of nicely right in there where we needed. And it's going to come in and touch off each of these little corners there to really get in there good. So very cool. To go back in, let's double check that stock was 0. Yep. So let's simulate. And if we play, it's going to come in and take care of all those little ones. Oh, we didn't actually set the depth. Cut levels, depth. We did 0.5. Set that to 0.25 as well. Let's regenerate that. That'll be nice and different. And this could take longer on other computers. I'm working with a pretty powerful computer here, and it still takes a good amount of time here to set up the operation. So if we go ahead and we simulate, and there we go. It's touching through all of them. And there we go. That's exactly what we want this to look like. So far, that looks pretty awesome. So now what we're going to do is we're going to come in and we're going to pocket out these guys here. So what we want to do is we don't want to pocket through the other ones we used as well. So, so we need to create the curve as well. And you can see that already has been booled out for us nicely. So create a pocket operation. Do axis pocketing. Select our regions. We're going to select this guy up there, that guy, and that guy. And we're going to pocket them down to that same ½ inch level. We use the 1/4 inch for this. I'm going to set our stock to 0 and our tolerance to 1 thou. We're not going to come in and clean it up. Step over of ½ corner cleanup loops, I'm going to set to inside, clean up those corners nicely. And we're going to set our cut depth to ½ inch, and we'll do the same. We'll do it in 2 steps. We're going to helix in, apply at all levels. Arc fitting, we're going to set down to 2000ths again. We'll use smooth cut connectors and generate. There we go. Created the 3 pockets right there. Let's take a look at what that looks like. You can see it's nicely pocketing out those areas. And I can speed it up here. That looks awesome. Actually, we forgot to select that middle one. Let's go in nice and easy. We can just jump back in. We're going to add that guy to it. And just regenerate. And it's going to add that pocketing right there. So if I just simulate to end, so we can take a look at it. There we go. That looks awesome. All right, so let's go back. What do we want to do with the letters? So I think for the big letters, we're going to machine these out as pockets. And then I think for the engineering and design, that's when we'll use the engraving tool. So just like we did before, we're going to do another 2.5 axis pocketing. Remove all. We're going to select our new regions. Select all these letters. And RhinoCAM will automatically determine the inside outside of those. Leave the quarter. Cut parameters. 0 stock, and let's set our tolerance to 1,000th. We'll turn on corner cleanup loops, which is new for 2016, as you saw in my last video. Cut levels. We're going to set this so it's not as deep. We're going to do 25, and we'll do it in 1. Helix in. Apply at every level. It doesn't matter. We're only doing 1 level. Set our arc fitting to 2000s, and we're going to use smooth cut connectors. And sorting, we're going to do minimum distance sort, so it goes through it fast. There we go. Now we can see that it created those as well. And we can just hit to end here to simulate right through it, and we can see what it looks like. That is really cool. All right, so now what we're going to do to finish up this, we're going to go ahead and engrave these bottoms here. So what we can do is we've got 2.5 axis engraving. We've also got V carving, which is pretty cool as well. V carving we may use for the letters here because it'll machine in between there with a V. So let's do the regular engraving for our arrows on the ends. And then we'll do V carving for that. So we'll do engraving. We're going to select all of this. We need to create a new tool for this because we need a V mill. And you can do it with a drill. You can do it with a center mill. You can see all these different types of mills. You've got taper mill, chamfer mill, V mill. So let's just call this engraving. And we'll leave everything else alone. Save as new tool. Hit OK. Just going through everything here so we can see what it looks and how we do it. So now with an engraving tool, we're going to set our cut depth to just 5 thousandths. We just want to basically etch the bottom with it. So here's the thing. Because this level is here, we've already cut down a 1/2 inch. We need to set where the top is. And unfortunately, we don't even have anything to pick here. What we do know is what we can do is we can come in here and pick the point, which is 0. What we're going to do is come and set it to -0.5. And the entry exit here, we're not going to enter and exit in anything. I think we're going to be fine. Sorting, we'll turn on minimum distance sorting. And you can see where it's coming in and created the paths nicely. So let's go ahead and take a look at what that looks like. And you can see it's not quite enough. So let's go ahead and alter our depth there. And if I go into depth in here, let's change this to 20 thousandths. Simulate. We can see that it's a little deeper. Still not quite a ton. We wanted to add more, we can. It could be because of the tool we were using as well, the taper on it. I know the ones that I use are, we don't need to go that much deeper. Let's try 100,000. We'll see what it looks like. All in one cut. There we go. Now you can see it's nicely in there. That's what we want. All right, so let's do some V-carve on the engineering and design. 2-axis V-carving. We're going to go ahead and select all of our letters. And RhinoCAM will again take into consideration the inside outsides of the letters that have like the D and the ampersand, like that. So for tool, I'm going to use the same tool here, but now we're going to go, actually let's create a new one with a little bit different of a taper. So our taper angle on this one was only 10 degrees. Let's change this guy to 45. And what that's going to do is like a 90-degree taper. So it's going to actually get in there deep, which we're going to have to play with the depth a little bit. And we'll go from there. I'll just name this Engraving 2. Okay. Feeds and speeds. Let's make sure our Engraving 2 is selected. Clearance plane cut parameters. All right, so we got to make sure we set our bottom to, or I'm sorry, our top to 1/2 inch. And we're going to try an engraving depth of 5 thousandths first. We'll start with that. Sort minimum distance, generate. And we'll see how that looks. Kind of going all over the place there. And actually what it did was it traced it anyways, as opposed to staying in between it. I'm not positive. I might have selected or not selected. But let's give it a little more depth anyways so we can kind of see it, especially now that I changed the tool. And I'm going to change the sorting to directional sort. We'll do, leave it on what it is. Not sure why it's jumping around like crazy like that. Either way, not quite what we were looking for the V carving, but I like the way it looks. Could be the tool that we picked. If I come in and measure here, see how it's doing that. We really didn't, but it is giving you the correct ends and everything. You can see how it's creating that V carve on the ends. So it's a different, it's not just following it, it is doing profiling on the inside of it. So it's doing it correct. And we can check out our parameters here. See if we add more depth, will it change the way it looks even more? Or maybe it's the tool. It very well could be the tool size we picked. Let's try 50 thou. You can see that it's doing it. Now it's really getting in there. So let's see how that looks. There we go. That's what we wanted. So it's obviously the depth is really controlling. We're showing a depth for the V carve when we're using that tool. And that actually looks great. I dig that. So if I turn off toolpaths, you can kind of see some of the shadows. That would make a nice little sign, don't you think? So this shows that you can easily import an Illustrator file right into Rhino and write toolpaths for it using RhinoCAM in not very long time at all. 20 minutes maybe it took us to do this. So one of our next videos we'll do is we'll take a picture or a BMP of a logo, and we'll use Rhino Art to create the curves from it and create the relief. That way we can machine directly from somebody's picture or design, versus if you have the artwork, obviously in Illustrator you have vector art and you can work with it very easily. I'm very happy with the way this came out. This is actually really cool. I may have to go ahead and machine this, but definitely not that big. That would be a lot of money in aluminum material. So if you guys have any questions, feel free to comment on this YouTube video or hit us up at info@appliedengdesign.com. I'm Mike, and thank you for listening, and we'll see you on the next video.